Welcome back to Saxon Math. This is lesson 40, using 0 as a placeholder and circle graphs. It's a new concept. When subtracting, multiplying, and dividing decimal numbers, we often encounter empty decimal places, such as these examples here. 5/10 minus 32 hundredths, or 2/10 times 3/10 would end up having a couple empties in the answer, or 12 hundredths divided by 3 would end up having an empty decimal place in that answer. When this occurs, we fill in each empty decimal place with a 0. In order to subtract, it is sometimes necessary to attach zeros to the top number. Like this one, we'd have to have a 0 here. We would have to include a 0 here and a 0 here because we have two places there. This would be like 1 divided by 3 is 0. You can't do it, so you have to have that 0 as a placeholder because the decimal comes straight up in the answer in a division problem. Let's look at example 1 here, 5/10 minus 32 hundredths. So if we were going to write the problem making sure to line up the decimal points, we'll fill in the empty places with 0 and subtract, like 50 hundredths and 32 hundredths. And when you subtract it, you end up with 10 minus 2 is 8, 4 minus 3 is 1. And how can you check subtraction? You could just add. You could add these two together, or if you wanted to, you could add these two together to find out if they're the other. You can't add those two together, but you could subtract 50 hundredths minus 18 hundredths if you wanted to do that to see if it'll end up being the other. Or you could do 18 hundredths plus 32 hundredths, and you'd end up with the other. If you did that, this would be 10, carry that, that'd be 50 hundredths, just as you see. If you did this one, this would be borrowing, you get 4, this would be 10, this would be 2, 32 hundredths. So you can see you get the other numbers that are in that particular problem. All right, example 2, subtract. We have 3 minus 4/10. We place a decimal point on the back of the whole number and line up the decimal points. We fill in the empty place with 0 and subtract. So this would be like 3.0 so that you can line up the decimal points in order to complete this problem. So 3, we'd borrow from that. This would change it to 10. This would be 6, and that would be 2. The decimal comes straight down in your answer. This would be 2 6/10, as you can see here. Example 3, when multiplying decimal numbers, we may need to insert one or more zeros between the multiplication answer and the decimal point to hold the other digits in their proper places. So for example, 2/10 times 3/10. If I'm going to multiply that, it's basically 2 times 3, but then I have to keep in mind that there's this place value and this place value, so I have to move it those 2 places. I have to move it 2 places from this position. I have to start here and go once, twice. So the decimal would be over here, but I have to have a place in that position as well. So I have to throw a 0 in that placeholder. So we multiply and count the 2 places from the right, and then we'd fill in the empty place with 0, and we write 0 in the ones place. And it asks, why must the product of 2/10 and 3/10 have 2 decimal places? Well, if you think about it, this is, as a fraction, would look like this. 2/10 times 3/10 would end up being 6 hundredths, and it's in the hundredths place that 6 would have to be represented in a decimal, so that would be in this position. That's the hundredths place. All right, let's look at another example here. Example 4, use digits to write the decimal number 12 thousandths. So first of all, you need to know where 12 thousandths is. The word thousandths tells us that there are 3 places to the right of the decimal point. So that would be in this position right here. So if you want to have 12 thousandths, that means we need to fit the 2 digits of the 12 into the last 2 places. The 12, and then we have to throw in some zeros to make placeholders. Then we fill in the empty place with 0. That would be 12 thousandths. Example 5, we're getting into circle graphs, which are sometimes called pie graphs or pie charts. They display quantitative information in fractions of a circle, and the next example uses a circle graph to display information about students' pets. So if Brett collected information from his classmates about their pets, he displayed the information about the number of pets in a circle graph. So they found out they had 16 dogs, 4 fish, 4 birds, and 8 cats. Question number 1, use the graph to answer the following questions. How many pets are represented in the graph? So if you've got 16 dogs plus 4 fish plus 4 birds plus 8 cats, this looks like the total number of pets would be 32, and the answer would be pets. Letter B, what fraction of the pets are birds? Well, if the total amount of animals is 32, that's the denominator. We found that out in letter A. And if the total is 32, that's the denominator, and then we're looking at birds only, so this would be 4 out of the 32 total birds is the fraction, but that's unreduced. It's unreduced because it looks like I can divide this one by 4, and I could divide this one by 4. So I'd end up with 1 1/8 in this case. The fraction of birds would be 1/8. And letter C, what percent of the pets are dogs? That's pretty easy to see when you look at that. And if you've got your fraction manipulatives still, you can pull those out and look at that. But you could see that dogs make up, you can see it splits it right down the middle here, guys and girls. So that means you've got 16 out of 32 if you really wanted to look at it as an unreduced fraction, but that would reduce to something pretty easy to see, 1/2. Example 6. A newspaper polled likely voters to survey support for a local bond measure in the November ballot. Display the data below. Display the data shown below with a circle graph and then compare the two graphs. So here's what we would have. This is the problem. We have 1/3 of the people support the bond measure. 1/3 oppose it. That means they don't support it. It's the support of the bond measure, so 1/3 oppose it and 2/3 favor it. If you recognize this would be 1/3, this would be 2/3, and if you were to add those two together, that would be 3/3, which equals 1, which also equals 100% of the people polled. So 1/3 oppose, 2/3 favor. So we want to look at it as a circle graph. You just need to create a graph that's in the shape of the circle. The bar graph shows that 1/3 of the voters oppose the bond measure and 2/3 are in favor of it. Using the fraction circle manipulatives that you have from investigation 2, you'd be able to draw a circle and divide it into 3 sectors. We would label one sector oppose and the 2 sectors favor. We know from our fraction manipulatives that 1/3 is 33 1/3%, and 2/3 is 66 2/3%. So we add these percentages to our labels. Here would be what you would get. So, and you might notice that this would be like 2/3 right here. So you can see that this is what's in favor, and this was what would oppose. That's what your circle graph would look like. And this is the same exact information as this bar graph. Same information, the bar graph, circle graph, just represented in 2 different ways. Let's try some of these problems. Let's do letter A, 2/10 times 3/10. For this one, you should have recognized that 2 times 3 is 6. And then you could count the place value that you need to move to the left from that position. You'd have to have it over 2 places. That'd be 6/100ths. The letter B, 4 6/10 minus 46/100ths. Go ahead and do that one. So if I put 4 6/10 and I'm subtracting, it looks like 46 has to go in this position, 46 hundredths. I need to throw in a 0 here to make this work a little easier. Then I would borrow, this would turn into 10 here, and I have 4, and this would be 1. Decimal comes straight down in the answer. This would be 4 and 14 hundredths for letter B. All right, do letter C. So this one, again, multiplying. So I have to make sure that I really don't have to line up anything here. I could have, when I'm multiplying and dividing decimals, lining up the decimal actually doesn't make any difference. And I know 1 times 1 is 1. So if 1 times 1 is 1, and then I've got 1, 2, 3 places I've got to have. So here's 1, there's 2, 3. So 1, 2, 3. Decimal would go in here in this position in the answer. So that'd be 1,000th. So if you think about it, for letter C, this would be 1/10 times 1/100th. And if you were to multiply that out in fraction form, you'd get 1,000th, because there's 1, 2, 3 zeros. Okay, letter D. Let me just put letter D right here. 4/10 minus 32 hundredths. So if I'm going to subtract that, I need to make sure I have a 0 here. This would end up being 10, and this would end up being 8. This would be 3 because we borrowed from that. This is 0, and the decimal comes right down. That means that we'd have 8 hundredths for letter D. Letter E, 12 hundredths times 4/10. Let me do letter E right here. 12 hundredths times 4/10. And I don't have to line up the decimals when I'm multiplying them. I just need to make sure I remember it's like 12 times 4. Well, I know what 12 times 4 is. That's 48. 8 and 4. And then I need to count the decimal places. There's 1, there's 2, and 3. So there's between all of those, that's 3 places I need to move it. So that means I've got 1, 2, and then I have to throw another 0 in to make it to a third place. This would be 48 thousandths for letter E. Letter F, 1 minus 98 hundredths. So for this one, for letter F, 1 minus 98 hundredths means I need to throw in a couple zeros as placeholders. I need to have that decimal in that correct position. If I borrow from this, this turns into 0, this turns into 9 because I'm borrowing 10 and I'm making this one 10. So 10 minus 8 is 2, and 9 minus 9 is 0. Decimal comes straight down in the answer, and this is also 0. So for letter F, it'd be 2 hundredths. All right, letter G, 3/10 squared. This is the same, remember, this is the same as 3/10 times, and my digital pen's going wonky on me here, so let me try to write a times symbol here. 3/10 times 3/10. This would be 9, and then I count the decimal places. There's 2 there, so that means I need to have 1, 2, decimal goes right there. This would be 9 hundredths. 3/10 times 3/10 is 9 hundredths. All right, and letter H. For that one, you need to remember it's the same concept. It's 12 hundredths times 12 hundredths. And from previous lessons we've done, you may remember what 12 times 12 is. 12 times 12 is 144. There's those 4s that the digital pen just does not like. And then I need to count 1, 2, 3, 4. That means I need to go over 4 places to the left from here. 1, 2, 3, 4. Decimal goes in this position, 0 right there. This would be 144 10,000ths for letter H. Letter I. Write the decimal number 10 and 11 thousandths. So 10, that's pretty easy. Everybody knows how to write 10, I hope. And then the word and is a decimal place. 11 thousandths. So I have to make sure I'm in the thousandths place. So if I put it here, this is 11, but it ends in the hundredths place, so that's not going to work. I have to make sure that I put a 0 in there so that the 11 ends in the thousandths place. So this would be 10 and 11 thousandths right there. And then letter J in the circle graph in example 5, what percent of the pets are cats? So we're looking at percent of pets that are cats over here. So it was 8 out of 32 pets. So if it's 8 out of 32 pets, that's the same as, and if we want to reduce this, let's just reduce this because I can see that this is divisible by 8. This is also divisible by 8. This would reduce to 1/4 our cats. And hopefully you know what 1 divided by 4 is, but if you don't know what 1 divided by 4 is, you could just do it. It would look like this. 1 divided by 4, decimal comes straight up in the answer. Then you'd have 0 here. That would be, 10, you actually can have 2 going there. This would be 8. This would be 20. 20 divided by 4 would be 5. This is the same as 25%. 25 hundredths is the same as 25%. So 1/4 is the same as 25 hundredths, which is also the same. It's asking in percentage, 25%. All right, thanks for watching, and I hope you have a great weekend, and we'll see you next time.